Alright, so let us do this lab today. We learned about DMVPN. So what are the things that you should know when someone talks about DMVPN? First thing is the protocol MGRE. This is the tunneling protocol, multi-point GRE. So when you say tunneling protocol, it negotiates tunnel with multiple endpoints. So to identify the group of endpoints, there will be a ID. So tunnel needs an ID. Tunnel needs an IP address. Tunnel needs the source interface. The mode is this. Remember, these things should be there in your configuration. Secondly, the protocol, next hop resolution protocol, NHRP, next hop resolution protocol. What does this need? This needs to learn all the spokes dynamically if it is hub. Neighbors are the spokes. Learned dynamically. So configuration related to dynamic learning we have to do. What else? Now this NHRP also needs an ID. We call it as network ID. Yeah. So you got ID for MGRE for the tunnel. You need ID for the protocol. So that we call it as network ID in NHRP. Optionally, you can enable authentication between the hub and the spokes. Authentication. So these three commands related to these three, you need to put it with NHRP command on the hub. On the spokes NHRP, you need to map the spokes to the hub. So those mapping commands will come into picture. And also the hub should be the next hop server, NHS. That needs to be configured. Along with that, these three things. When you do that, your DMVPN is ready. Okay. So DMVPN is ready just by doing this. And if you want protection on top of it, you need to enable IPsec. Okay. So this is what we are going to do. When I configure, you should expect these things. In the configuration, you should not remember memorize by heart commands. No. Now you are going to form DMVPN. And we need to know what all protocol involved. We learned it in the previous class. Now we need to know how to use those protocols that you learned. That's what we are going to do in the lab environment. Let's go to the lab. Now we need to form tunnel between the hub, which is the single point, to those three spokes which are multi-point. This is multi-point GRE scenario, DMVPN. So I go to the hub router. First of all, I want to check whether I can reach the spokes. Ping the spokes public IP address. ping 200.1.10.1. This should ping actually in order to start our VPN. Show IP OSPF neighbor. Oh, the OSPF is not running. Let me do that. Show IP protocol. OSPF is there, but why? Show IP interface brief. It has got an IP address. Okay, right. The problem is the middle router. This is the internet cloud of a router. I have offed it. It is off. Alright, once we on it, it will work. So let's wait for some time. I should see OSPF coming here. Okay, now I think we will be able to ping the spokes. Okay, I'm able to ping spokes 1, which is RTR3. This is the one. I'm able to ping RTR3. Let me ping, sorry, not this one. This is RTR3. I'm able to ping. Now let us ping RTR4, 20 here. And then router 5, 30.1. Alright, we got reachability from the hub. Using this reachability, MGRE will work. Now, go to the interface tunnel. Interface tunnel. I can give any number between 0 to this. So I'm going to start with 0. Only one tunnel you can form neighbor with many. Tunnel needs an IP address. So for the hub, what is the IP address I mentioned here? 10.10.10.1. All right. Now what is it? Sorry. All right. IP address is done. Next is, let us say the mode. IP, tunnel mode, not IP. Tunnel mode, GRE multipoint. This is called MGRE. Next is tunnel needs the interface to use, the physical interface, the WAN interface. So I'll say interface, tunnel interface. Tunnel source interface, gig. The interface name is G01 here on the hub, G01. Alright. I say tunnel needs a key. So tunnel key. See, all the commands are starting with tunnel. Alright. What all we have discussed here? Tunnel IP is given, mode is given, source interface is given. Now tunnel ID is needed. So that is what I am doing now. That is called tunnel key. And give a number, and it should be the same number on all device. I'm going to give 100. 100. So all the tunnel related things over. What is next? NHRP related things. These 4 things. right? Four things. IP NHRP. First thing is I want to authenticate. I'll say Cisco 123, all lowercase. Next is this NHRP needs an ID. I say IP NHRP, network ID, let's say 10. If I say 10 here, every device should have that same 10. Next is this should dynamically register the spokes. So I say IP NHRP map, correct? Yeah, map multicast dynamic. So when the spokes using multicast, when it comes to register, this will dynamically register them, learn their tunnel interface IP plus the WAN IP. Next, what is the left? I think everything is done for the spokes. Okay, automatic network ID. Sorry, authentication network ID. This. Okay, spokes registration done. Done. Now that's all actually on the hub router. What is next is I need to enable EIGRP or any protocol so that on the tunnel and the loopback, see we have a loopback. I repeat, I'm not going to enable EIGRP on the WAN interface. So there's going to be a tunnel established between these edge routers. Inside the tunnel, the LAN network need to be advertised. This should be advertised here, to be learned here through the tunnel. So I will run EIGRP only for the loopback interfaces, which is like a LAN for us, and what? The tunnel interface, this 10 network. So I'll go here, router EIGRP 100. The network, the tunnel network is 10 network, and the loopback network is 1 network. No auto summary. Done. We have finished router 1. Hub is ready. Let me go to spokes. Hey, let us finish another hub, okay? Dual hub. So that load sharing can be done. Okay, so the other hub, I think it's already there, down. Router 2. Enable config T. Do I have IP addresses? Show IP interface brief. Yeah, it is there. So all that I need to do is show IP protocol. Do I have OSPF? Okay, good. Show IP OSPF neighbor. Good. Okay, all that I need to do is configure the hub. Configure hub interface tunnel 0. Tunnel IP address is according to what we have here. I'm going to give 10, 10, 10 to then I should connect this router in the same network here. If I need to use 10, 10, 10, yeah, it's tunnel only. Yes, sorry, that is right. 10, 10, 10, 2 can be in same subnet. It should be in same subnet. Okay. Tunnel IP address is given. Tunnel mode, GRE multi-point. What else? Related to tunnel, is there anything else left? Tunnel source. gig Ethernet. The interface name is G01. Alright, what else? Okay, sorry, NHRP configuration still not done. IP, okay, one more thing, I think tunnel key. I think we gave 100 there, so I'm giving the same 100. Okay, and that's all I think related to tunnel. Now IPNHRP. First thing is the authentication. I remember I gave Cisco 123. Then this is a hub, so it needs to learn the members dynamically. So IP NHRP map command multicast dynamic. Oh, dynamic. What else? I think for NHRP network ID is not given. IP NHRP. See, all the commands starts with IP NHRP, IP NHRP. All the tunnel commands will start with tunnel. Network. I gave 10 there, so I'm giving 10 here. That is all. Right, I think the commands are now easy for you to remember. Show, run, let me show you interface tunnel 0. IP NHRP authentication, IP NHRP network, and then tunnel source, tunnel mode, tunnel key. I configured authentication. I also gave multicast dynamic. It is default, so it is not showing. I remember I gave where it is. Yeah, I have given IP NHRP multicast dynamic, but it is not displayed here. It's not shown here, but it is there. It is there by default, so it's not showing. Multicast dynamic is default. But let me try giving one more time, because in some iOS I've seen it. It shows IP NHRP map multicast dynamic. Yeah, it accepts. Show run interface tunnel 0. Okay, it won't appear here. In the running configuration, it won't appear. And then the tunnel 3-line configuration looks good. Let me also verify on router 1 once. On router 1, again I want to verify the same. Show run interface tunnel 0. Okay, here also the same condition. IP NHRP map command won't display. Alright, that's all about the hubs. See, there are 2 hubs we have now. In the production we used to have 2 hubs. That's why I kept 2 hubs for redundancy. Now let us see the spokes configuration. This is spokes 1. RTR3 is spokes 1. Interface tunnel, oh no, sorry. Hub 2 don't have now EIGRP loaded, so let's put EIGRP on hub 2. EIGRP I forgot to put. Router EIGRP, I gave 100 there, so 100 here. Networks are the 10 network, which is the tunnel. And if you see, because it's a redundant hub, I keep the same subnet here, same subnet. In the real world, we will have some internet here. I'm just simulating that. Network 1. No auto symbol. Done. Now going to the spokes side. See, what I'll do is I'll use the spokes configuration, which I configure on one router, to paste it on all other routers. Only on one router I'll configure. Alright, so watch carefully. Most of the things that we learned in hub repeats here. Only 2 line of extra configuration you will find in spokes, 2 line extra. NHS command and mapping is not dynamic in NHS. Okay, let us start. The tunnel IP address, according to the picture here, is 10.10.10.11. Tunnel mode is GRE multiple. These are all same configuration, no change. And then what else? Tunnel related, tunnel key. Alright, these 3 are same like what you did in tunnel source. Here tunnel source is G00. So these things are same. These configurations are same. Like hub. Now NHRP configuration will be slightly different, but some commands are same, like IP NHRP authentication Cisco 123. This is same command. IP NHRP network ID, I gave I think 10 there. Yes, this is same. What is different is this. See, IP NHRP, we were using this command map multicast dynamic, right? Instead of dynamic, we have to give the NBMA address, means the public address of the hub. Let me give the hub, first hub 200.1.1.1. Right? And also I have another hub, so another hub IP is 201.2.1. Done. So this is to say that go to this address and get registered. Secondly, IP NHRP map, I need to tell the tunnel IP address of the hub 1, which is, you see, tunnel IP address of the hub 1, which is 10.10.10.1, followed by the NBMA address, the public address of hub 1. The public address of hub 1 is 200. So I repeat the same command but with different IP address. The reason is this is 2 hub scenario. I am trying to match with the real world. 2. Done. So this is also done. Now only one more command left. IP NHS means next hop server. Sorry, NHRP next hop server. Here you need to give the tunnel IP address of the hubs. So hub 1, you see, the IP address of NHS is 10.10.10.1. That's it. This is for hub 1. Hub 2 is 10.10.10.2. That's all. Now when you enable EIGRP, you should form neighbor. Let's enable EIGRP. All tunnel related is done. Now I'm going to enable EIGRP and you will see 2 neighbors getting formed. 2 neighbors, who are they? Hub 1 and hub 2. So for that I see router EIGRP 100. Networks, or one is Lubeck network, another is 10 network. Yeah, look at this. 2 neighbors come, which means tunnel is ready. If tunnel is not there, this is not possible. You see, the EIGRP is forming neighbor via tunnel. We don't run EIGRP in the internet here. Alright, now I'm going to copy the tunnel interface configuration and only the IP address need to be changed for these two spokes. So I'll paste it in a notepad. Earlier I tested with my topology, so I have the configuration here. I'm going to just replace with what I copied from there. Okay. Now this is for router 4, RTR4 with spokes 2. Spokes 2 is 12 here. So I say 12. All the rest are same. There is no difference. There is no difference. All the rest are same. So what I do, I copy this whole configuration. Okay, here it is 4. For RTR, EIGRP is 4. Copy and put it on router 4. What happened? Okay. I pasted nicely. What's wrong? Show IP EIGRP interface. Oh. Why it's coming out? Oh, there's an exit here. Okay, this EIGRP is coming out. I don't do this mistake. I don't know how it went. Okay, as soon as I paste now it will come. You see, EIGRP will come. Cool. EIGRP forming neighbor with 2 hub routers. These two are 2 hubs. Excellent. What is next? Another spokes is there. It is 13. All the rest are same, so I copy. Okay, here it is not 4, it is 5. Now I put this on router 5. Okay. Now again, I'm expecting to know. Wonderful. Alright, so we have almost come to the end of this configuration, and then we need to do verification. But again, I'm telling you, it's not still fully finished. There's something related to EIGRP on DMVPN you will see now. I'm going to say what it is shortly, but let us start verifying. The best verification command is this: show IP DMVPN, show DMVPN. See, it says that you have tunnel up with 2 hub. See, easy to remember this command. Alright. Now, it is up. Status is up. These two are 2 hubs. Let me go to the hub and show you the same command. Hub router. Show DMVPN. I see 3 spokes. All are up. See the difference here. Hub learns the spokes dynamically, so it is D. Whereas if you go to spokes and see, it will be S. In spokes you will see yes, because we statically say the hub IP address while configuring. You remember? We statically say the IP address. See, statically we say the IP address of the hub. Alright. Now what is next? Check the routing table. Show IP route. I have the route to reach 111. But what about 222 and wait a minute. What about 333 and 444? I'm saying only 111, that is hub network IP. Why am I not seeing 333 and 444? The reason is EIGRP split horizon. I'll explain you what it is. I'll explain you what is EIGRP split horizon. You might have heard about split horizon in RIP. Same concept here also. See, this network is learned in the hub. Even this hub will also learn. But what they don't do is, whatever they learn on this port, they will not advertise on the same port. They won't advertise. If there is another port here, they will advertise. But not on the same port back. So if it is not coming back, then these guys cannot learn. Hub has to receive and give to spokes. They don't give. Even though there is NHS, you see, even though there is NHRP mapping, listen, go to hub and see. Show IP NHRP, NHRP summary. NHRP, not summary, NHRP map, I think. Okay, NHRP, yeah, NHRP. Even though this hub knows about all the spokes, it knows spokes RTR4, RTR5, RTR3, and their public IP addresses, you see. You see, to go to RTR, where am I? To go to RTR5, the public IP address is this. It knows very clearly the public IP address. To go to RTR spokes to tunnel 12, this is the public. It knows very clearly, but it won't give, because EIGRP has got a policy. What policy? Whatever you learn in one port, you should not give back on the same port. Now we need to cancel this if the learning should happen. So go under interface tunnel 0, no IP, split horizon, EIGRP 100. One more thing is next hop self. No next hop, no IP, EIGR, no EIGR, no. I think no IP. Next hop self. Next hop self, EIGRP 100. These two things you have to do. After you do this, now you go to router 5. And check the routing table. Last time when I was checking the routing table, you were not having 33334444. But now You have all of them. 3, 3, 3, 3, 4, 4, 4. Now you can have spokes to spokes tunnel. You see, I can ping spokes. Spokes. I'm right now in spokes 3. I'm right now in spokes 3, which is router 5. I can ping spokes 1, which is RTR3. See, I can show you. Ping 3333 with a source of 5555. I'm able to re-ping. You know how? Because router 5 has downloaded the NHRP map from the hub. I'll show you that. Show IP NHRP. You see? These mappings. How this came? This came dynamically from the spokes. So understand the logic. First, the spokes go and give their information to hub. And hub, when they want to talk, spokes, when they want to talk to another spokes, they go and approach the hub, get the information downloaded, and then use the shortcut to go and reach the spokes. For example, to prove that they are not going through the hub, I will trace route and show you. You will see it won't go to the hub, it will go straight to the spokes. I'm on router 5, I'm tracing the route to router 3. See the next hop, what it comes. The very first hop. You see, 10, 10, 10, 11 is what? Spokes. It goes directly to spokes, just one hop. Spokes to spokes, dynamic tunnel, DMVPN. Right? See, you have to go through yesterday's class if you didn't understand today. And then you go through this video. And then you will be able to get the story fully. You also should do the lab once, at least once. After learning, not simply doing while watching that class video. After learning, you can use your notebook and write the commands and then go and apply that, and you can do the lab like that. That will also be a good help to understand the concept in depth. Any question?
What configurations are there on that 0.6?
That is internet, nothing. It is just to provide connectivity between these routers. OSPF, let me show you. 0.6 internet router, nothing. No EIGRP, nothing. No DMVPN, nothing related to any VPN. It is just like an internet. Show IP protocol. You see, only OSPF is running to connect. Okay, no IP interface brief. See, show there is no tunnel interface. Show IP, EIGRP, neighbor, nothing. Show IP, EIGRP interface, nothing. It is just like, internet I have. And I enable OSPF so that these spokes and hub can ping each other. Now, I want to check by shutting down the hub. I'll go to hub 1 and shut down. After shutting down, I'll shut down the physical interface of the hub. After shutting down, I'll see whether the ping which I was doing earlier is still possible. Go to router 5 again and check the routing table. Show IP NHRP. Okay. I have this table. Yeah, I have this table. Now I want to see whether show DMVPN. Good, this is what I was expecting. Now what do you see is there is only one hub. Sorry, there are two hubs. Sorry, both the hubs are still up. No, I shut down. Why it's not showing down? It will go down. Maybe it takes time. This should go down. 10, 10, 10, 1 is who? 10, 10, 10, 1 is this guy, hub. I think I shut down the right interface. Yes, I did. Anyhow, let's try pinging. Show IP route. Do I have the routes? No EIGRP routes. No EIGRP routes. So still it is holding the hub 1. Hub 1 failed. Show IP EIGRP neighbor. But the tunnel is still there. This tunnel should go down. No. It's right. Now it is only with hub 2. This is perfect. I think in hub 2 EIGRP has got the issue. This is showing correct. Now, yes. You know what? On the on the hub 2, we did not configure those EIGRP commands under the tunnel interface. You see, show IP EIGRP interface. We do have it, but not on the tunnel, not on the loopback interface and the split horizon cancellation on the tunnel. So let us do that. Show IP interface brief. Do I have loopback? Let me add the loopback interface, loopback 0 IP address. This is the problem. I didn't configure. Secondly, interface tunnel 0. No IP split horizon EIGRP 100. No IP next hop self EIGRP 100. Okay. Now I should see the failover happening. I'm on router 5. I can now see the routes. Alright. Still I'm able to ping without hub 1. I am able to ping this through hub 2. I'm able to ping. Now I'm going and shutting down hub 2. I'm shutting down hub 2. Because we shut down both the hubs, show IP NHRP, as long as this table exists. Oh, EIGRP will not give route. Sorry. Let me check the routing table. Show IP route. Yeah, EIGRP will not give. Even though NHRP table is still not expired, the ping won't happen because of EIGRP. I need a hub. Without that, it won't ping at all. I'll go with one of the hub. I'm going to bring hub 1 again. No shit. After this comes up, EIGRP will also come up, then I'll be able to ping. Go to router 5 now and check the routing table. Wait some time. Okay, now EIGRP has come. It should ping now. Wonderful, you see. Ping now. the ping happens. So at least one hub should be there for the ping. That is what I was proving you. If both are dead, no way. That's why we take 2 NHRP hub, because we need at least one. Hey, do you have any question?
No, sir.